Ever wonder how we find planets orbiting young stars, especially those hidden within bustling stellar nurseries? It's a tricky business, but incredibly important. Young stars are like teenagers, full of energy and unpredictable behavior, making it hard to spot their planetary companions. Their brightness flickers, they have strong magnetic activity, and they often reside in crowded, blurry environments. This makes it challenging to detect exoplanets, but it's crucial because this is when planets are really on the move, migrating to their final orbits. So how do we overcome these obstacles? Scientists are turning to powerful tools, like the Nancy Grace Roman Space Telescope, to peer into these chaotic regions. A recent study focused on the Rosette Nebula, a vibrant star-forming region filled with stars about 10 million years old. Using the Roman Space Telescope's capabilities, researchers aim to predict how many young exoplanets it could find in the Rosette Nebula. They utilized the Roman Exposure Time Calculator to determine the telescope's sensitivity to the nebula stars. They then ran simulations to see how many planets they could realistically detect. The results are promising. They predict that a month-long survey could find around 33 plus or minus 9 young, transiting exoplanets. Even a shorter, 2-week survey could still detect approximately 29 plus or minus 8 exoplanets. And this is the part most people miss. The longer the survey, the better the chances of finding planets with longer orbital periods, particularly those orbiting Sun-like stars, FGK stars. However, even within 2 weeks, they expect to find many planets orbiting smaller, cooler stars and dwarfs. The majority of these detected planets are expected to be super-Earths and sub-Neptunes, with sizes between 1 and 2 times the size of Earth and orbital periods of less than 8 days. But here's where it gets controversial. Currently, we've only found 3 planets younger than 20 million years. This new survey would significantly expand our understanding of this early phase of planetary development, a time when planets are still puffy, the stability of closed-in orbits is uncertain, and planetary migration is potentially still happening. This research also highlights how the Nancy Grace Roman Space Telescope can help us identify promising targets for follow-up observations using other powerful telescopes, like the James Webb Space Telescope, the Vera Rubin Observatory, and the Habitable Worlds Observatory. What do you think? Are you excited about the possibility of discovering more young exoplanets? Do you think the Roman Space Telescope will revolutionize our understanding of planet formation? Share your thoughts in the comments.